Hey folks, welcome back to another video. Today we're looking at question 11, container with most water. The way we'll be approaching this problem is by using two pointers, one that starts from the left, the other one that starts from the right. And what we need to do is that anytime we have these two pointers, we want to calculate the area that's between them. And if it does exceed the maximum result that we have stored so far, we overwrite it. If not, we keep continuing our computation. And the way we do that is whenever we want to move in closer, we want to make the right pointer meet the left pointer. The way we see that is whichever one is the lesser height of the two. So if you're looking at the left and the right, in this example, like example 1, so you start from here, right here, where I'm pointing my arrow. You start with the one right here and the one right here. So L will be starting from the leftmost side, and R would be starting from the rightmost side, and then we calculate the area between that. So we take the minimum between these two and then calculate the area. And to move it closer, we decide, hey, like which one is of the L and the R that we're looking at, which is the greater height. So we will keep the pointer as is, and the other pointer, which is lesser, which has a lesser value, we will move that in. So if the lesser value is the one on the left, we increment the left pointer. If not, we decrement the right pointer, and that's how we keep moving in and calculate the area. So that's how we solve the problem. So let's jump right in. The first thing we need to do is get the height. Do we actually need the height? Yeah, we would. So n would be equal to h dot length, and L is equal to 0. R is equal to n minus 1, and we would also have max area, which would be equal to 0, and then we have the while loop, and this says if L is less than R, while this is true, we keep doing the computation, and this is how we do it. So max area would be equal to the maximum of the area that we've seen previously, or the new area that we're calculating, which would be mat.min of h of L or h of R. So you'd need to get the minimum of the two values that we're looking at, and you would multiply that by the different distance between them. So R minus L. Alright, so if it is true, if this area would be true, it would be updated. Otherwise, it would be kept as is. And then you need to know how exactly you're moving the pointer, whether you're moving the left pointer inside or the right pointer inside. So that would be if h of L is greater than h of R, you would increment L, else you would decrement R. And in the end, you would just return the max area. Alright, so let's quickly compile this and see if it's okay. H of L, H of R, if L is greater. Oh, so sorry, actually I guess this would be switched. Okay. Perfect. So that makes sense. I hope that makes sense. So let me correct my mistake. So if L is greater than R, you want to keep the anchor right, the pointer as is for the left one, and you would want to decrement R, else you would want to increment L. Alright, so let's talk about the space and the time complexity. The time complexity of the entire solution is O of n, since we would be iterating throughout the entire array once, and the space complexity would be O of n, since we're not really using additional space, we're just using constant space to store our result. Awesome, so that's the solution for this problem. If there are any questions, please let me know in the comments below, and please don't forget to subscribe. I would really appreciate that. See you all in the next video. Peace.